Sketching polynomials. It's often useful to be able to get a rough sketch of a polynomial even if you don't have time to sit down and calculate a bunch of points and get a really accurate shape. So there are a couple of things that a polynomial tells us that makes them fairly easy to, generally sketch. Now, we think of polynomials in this class as sort of having two sort of matching parent families, and those are x squared, this nice parabola shape you see to the left, and x cubed, which is often described as this sort of snaky shape that you see to the right. Now, all polynomials will either have an even degree, like x squared, or an odd degree, like x cubed. All polynomials with an even degree are going to have these same end behaviors. See how x squared points up in both directions? All even polynomials will have end behaviors that go in the same directions. See how x cubed has opposite end behaviors? Its little arrows point in opposite directions. All odd polynomials will ultimately end up going in opposite directions on either end. So like x to the fourth and x to the fifth and x to the seventh, those will look like x squared and then x cubed respectively. So let's make a chart to think about these end behaviors. So we think of polynomials as even or odd. All the even ones look kind of like x squared. All the odd ones look kind of like x cubed. So they're even or odd. Now the leading coefficient, that number out in front of the term that has the degree, will either be positive or it will be negative. So I want you to think about the effect that a reflection has on a graph. When we've talked about function transformations, what does a reflection do? All right, good. A reflection is going to reverse all of the values in the graph. It's going to reflect it essentially over the x-axis. So that's what effect a negative leading coefficient will have on the graph. It's going to reflect it. So if we have an even degree and a positive leading coefficient, our end behaviors are going to look something like regular old x squared. If, however, we have an even degree and a negative leading coefficient, that function is going to end up pointing down for both of its end behaviors. If you have an odd degree and a positive leading coefficient, the function's going to have little end behaviors that look like x cubed. But if you have an odd degree and a negative leading coefficient, those ends are going to reverse and it will end up going up to the left and down to the right. Now, the degree determines how many direction changes you could possibly have between your two end behaviors. So the leading coefficient determines end behaviors, and the degree determines the number of possible direction changes. For instance, let's take a look at this polynomial, and this polynomial. See how general these sketches are? I can tell a lot about these, even though I don't even have them graphed on a coordinate plane. Now, see how on the first one, the arrows point in opposite directions. This polynomial looks like it has an odd degree. Since the arrows go down to the right, down to the left and up to the right, we can tell it has a positive leading coefficient, and we need to determine something about the degree, but maybe we can't do that yet. So let's look at the second one. The arrows point in the same direction, so it appears to be an even degree, and the third one as well. Now, since the arrows point down on the second one, but up on the third one, that second one looks like he has a negative leading coefficient, and the third one looks like he has a positive leading coefficient. Now let's count direction changes. On the first one we have 1, 2, 3, 4 direction changes, but a fourth degree polynomial would have same end behaviors. So let's look at the second one and the third one. In the second one, we have 1, 2, 3, 4, 5, 6, 7 direction changes, but that one needs to be an even polynomial. And in the third one, we have 1, 2, 3, 4, 5 direction changes, but we also know that this is an even polynomial. What could be going on? Well, back up to the first one. 4 direction changes indicate a 5th degree polynomial. 7 direction changes indicate an 8th degree polynomial. And 5 direction changes indicate a 6th degree polynomial. So the number of direction changes is always one less than your potential degree. At least, it can have less than that. But a degree determines direction changes, and a polynomial can have up to n degrees and always n minus 1 direction changes. So always one less direction change than you have degrees.